Hello and welcome to Engineering with Rosie Live. Can you please give me a wave in the comments and tell me where you're calling in from, and also tell me a bit about yourself. I'm interested to see what kind of mix of people we have here today. Maybe you're a student or a parent of someone who's thinking about becoming an engineering student. Maybe you're a recent grad or somewhere in the middle of your career, or even I know that a lot of people commented on my post who are towards the end of their career and wanted to share tips with the new and upcoming engineers. So let me know. Let's see what we've already got here in the comments. From Sweden, got Doctor who is worried about whether his device is going to get destroyed by a storm. Got the conservator here. Good evening from the Netherlands. Good morning from India. Okay, so that's really, really cool. I've been trying to plan out a time that can kind of suit everyone. It's hard for me because I'm in Australia, which is the most inconvenient time zone of them all, but it does seem like I've managed to capture a good good time for most people around the world. Hashim Oog watching from Sweden. Okay, so now we've got Sundan here. He says his nephew is graduating from Kansas State University next month for engineering. Okay, so I guess you're watching on behalf of him for tips. We've got Charlie Goodson here in East Texas, currently a junior in mechanical engineering. So I guess junior, that means your second last year. Is that right? Okay, then we've got MDM, a master's student for UREC, and I don't know what UREC is, sorry. Currently enrolled in Sustainable Energy Systems Management. My specialization will be blockchain and microgrids. Oh, that's exciting. That actually ties in pretty well with the most recent video released on the green commodities certification, and microgrids are something that I'm really excited about. So I think you've picked a good topic there. We've got Tech Terminator from India, Craig Gillett from England, Mayank Cheaton from Texas, PhD candidate in wind turbine, focusing on blade structures and turbine loads defending in a month. That sounds very similar to the way I would describe my PhD that I finished about 5 or 6 years ago. So that's interesting. John Coppola, composites. Christopher from Nigeria. Hello. I don't know if I've heard of you from Nigeria before. And we've got same commenter, Hashim Oog, IB student last year, planning to enroll in energy engineering fall of next year. Cool. And Emmanuel Floric, who is a geek fan from France. I think that we're probably all geek fans here. So welcome to you. Okay, I am just going to now share the poll that I did in preparation for this. So I asked engineers, already working engineers, what's the biggest difference that you experience between studying and working as an engineer, and what advice you'd give to current students to help make that transition. So there were a few common threads here, and I think one of them really matches what I also think, which was about how, here, in my experience, it's incredibly important to know what the customer actually wants. I still struggle with no one cares if your solution is elegant, only if it fulfills their requirements. They never tell you their actual requirements. Too much focus on theory in education, and then the ever-evolving world of rules and standards in the career. And so for me, the biggest difference between studying at university and working as an engineer is that there's no one to tell you what the problem is. It's up to you to figure out the problem. And I'm going to come back to that in a minute, because that's actually the most common question that I get asked from people is, people or students write in and ask me if I can tell them what topic that they should study for their research project, whether it's in their undergraduate study or their master's or their PhD. So I am going to definitively give my advice once and for all, because I get asked that too often to be able to reply to everybody individually. Okay, so I just wanted to start by giving a little bit of a background. Okay, so I just wanted to start. I've got a PowerPoint presentation. I know it's a bit geeky, but I did just want to share a little bit about my background, and yeah, so you can understand what my education history is, and then I think that will help to proceed. Okay, so I'll start with school. Like when I was really young, I actually had my hobbies were sewing and baking and ballet, cycling and music. So I have included that because a lot of people think that, if you're going to become an engineer, then you're probably a tomboy playing with Lego and building stuff. And I mean, I did that a little bit, but mostly I had pretty traditional girly subjects. And I would say that some of them really actually were excellent engineering training, especially the sewing and the baking. So I would definitely encourage anybody who has these kinds of hobbies or, knows a young person that does, like encourage them to investigate whether or not they might like to actually really become an engineer, because these sort of, creative and problem solving hobbies, and it also gives you very good spatial skills and baking good chemistry skills. I think that that's a really good start for a technical career. In school, my favorite subjects were science and PE. I basically just could not get enough of science, in particular physics. So in what we call college here in Canberra, it's year 11 and 12. So when you're like 17 and 18, I basically just did maths and physics and also some chemistry. Then at university, I actually started with I had the intention I was going to study aerospace engineering. I was going to do it at Sydney University, but then I realized that I went to Sydney for the Olympics and realized I didn't want to live in a big city. So I decided to stay in Canberra and do my degree at the Australian National University. I did a Bachelor of Engineering, and at ANU, they only have systems engineering. So that's what I did. And I did a double degree with an arts degree. So in engineering, my major was materials and manufacturing systems. And in arts, my major was philosophy. And then I did 1 year abroad at the University of California, Davis, where I did an aerospace major. So I was able in that 1 year to do all of the core aerospace subjects. And it was really good to get that really different kind of cultural perspective. The university system is very different between Australia and America. So that was good to find out. And then the most important thing that I did during my degree, I would say more so than all the coursework that I did, the most important thing was this extracurricular project, the SAE Aero Design Competition. A lot of people are familiar with the Formula SAE, where students design like a race car. And this is similar to that, except that we designed an aeroplane. And this is a team in the first year that I did it. So this photos from the first team. So we built we designed, manufactured a remotely piloted airplane, and then we actually went over and tested it in California in the Air Design West competition. And yeah, there was just learned so much from that in terms of like practical engineering skills, in contrast to like what you learn at university, where the problem is really well defined. This extracurricular project gave me my first real taste of, someone's not telling you what the answer should be. There's like a really open problem, and you've got all these extra constraints that you wouldn't necessarily see in a homework problem. So, we had to fundraise to get the money, had to build it, lots of late nights in the workshop. I will say that there is nothing more satisfying than designing, doing all the calculations to calculate the lift of an aeroplane, then making it and seeing, your calculations actually take off. There's like, there's no hiding with an aeroplane. If you get the calculations right, it takes off, and if you get it wrong, then it doesn't. So for me, that was a huge part of my engineering education, and I definitely learned more about becoming an actual engineer doing that project than from the subjects. Okay, so now I just wanted to answer any questions about education. I've got some that I asked beforehand in case I wasn't sure actually how many people would actually show up to how many students would show up to this live stream, because I know that normally my audience skews pretty old. So yeah. Let me know if you've got any questions, and if you don't, then I have some that some other students have sent me in previously. Okay, so what have we got in the comments? We've got from John Coppola a couple of interesting comments. Prototyping a plugin for FreeCAD to create layer patterns. And then he says, I sewed my own sails together as a kid out of blue tarps. And yeah, so you get it. You get that the sewing is really good engineering training. And so I work in composite materials, and that's all fabrics. And in the factories, and also in the design the workshops where we use to prototype and stuff, they do hire actually a lot of people who used to be sewers, used to sew for a living. So I think that that it's really good in composite materials to have that experience of what you do with sewing is, you take a 2D fabric and you've got to make it into a 3D functional thing. And so to me, that's really good engineering, and also structural, because you've got to reinforce the seams that get a lot of wear and make sure that it moves. So yeah, I think that's a good one. Okay, so Sondon says fundraising and money is your favorite part, isn't it, Dr. Rosie? Yeah, I did not enjoy that part so much. I got roped into it on my first go with that aero design project. I was the youngest one. I was in my first year, and the other two guys were in their final year. One of them, Mike, he kind of started the whole team there at ANU, and it was his final year project. And so, he was doing all the design. The other guy, Dean, he was the pilot, and I joined on just, to kind of fill in the gaps. So I was, just another pair of hands in the workshop, and then all the fundraising. And I have to say that you might not realize it, but even if you just go get a normal job in an engineering company, you're still going to be fundraising all the time. Like if you have a project that you want to do that you think is important for the company or for the direction of the product that you're working on, you are actually going to need to fundraise within your organization to get people to commit money for you to be able to do that project. So I wouldn't underestimate how much fundraising is a skill that engineers are going to need, regardless of whether you're starting a company or you're going to work for a nonprofit or anything like that. MS in Germany in renewable energy. Is it a good career for a person from India and a freshman? So it's going to be really hard for me to comment on. I know that the systems are different all around the world. I only have experience with the Australian university system and the US one, and then I have worked in Australia and in Europe. So and I've worked I've worked with interns and graduates in Europe as well. So I have a little bit of a sense of those education systems and workplaces. So India, I'm not so familiar with, so I can't comment specifically on that. I know that there's plenty of renewable energy engineering jobs in India, like everywhere else. There's my old company that I used to work for, LM Wind Power. They have factories in India, and also a lot of the engineering is done there. So from the Indian colleagues that I worked with were doing a lot of computer stuff. So lots of simulations, whether it's finite element analysis or CFD, and then also a lot of manufacturing support, because there were factories there. So those are the areas that I've seen experience with in India, but I would have no clue if that kind of, encompasses everything that's available there. Okay. All right, so that's most of the questions that I'm getting through now. So I'm just going to go to some of the questions that I frequently get asked and answer them. So I'm going to start with, what subjects should I study? Because I get asked by a lot of people who are starting out in engineering, what kind of engineering should I do? What subjects should I choose? And I'll basically just tell you how I approached that. So when I started university, I actually barely knew what engineering was, even though my older brother had studied it. and even my grandfather was an engineer, though I didn't know him. I really, if I'm honest, the reason why I did engineering is because I loved physics so much. I also liked maths a lot, and if you're good at physics and maths, then you do engineering. That was pretty much the extent of it. My dad had also mentioned to me, like, I thought I wanted to study physics, and my dad had mentioned to me that most of the physics, or many good physics jobs, actually go to engineers, and that I should probably start with an engineering degree. And because they're so similar, like a mechanical engineering degree and a physics degree are so similar in their first year, it's you can change without losing any time after the first year. So I started engineering degree, systems engineering degree, and realized that I love studying physics, but what I really like is to use the physics to solve real world problems, and that's exactly what engineering is. So, yeah, I got good advice, and I was in the right place. So I would suggest for other people, if you don't know exactly what you want to be when you start university, just start with what you like to study, and you'll figure out more about what you want to do as you go along. So kind of pay attention while you're studying. You wouldn't want to get to the end of your degree and still have no clue what you wanted to work as, but you can kind of keep an eye out as you're studying. Which subjects do you like and are you good at? And kind of investigate what kinds of jobs that might lead to. And then eventually, once you've figured out what kind of job you'd like to do, then I would suggest that you start making sure that you're doing subjects and projects, like choosing project topics that are going to help you get interviews for that kind of job. So you might even start looking at job ads for a job you'd like to do a year or two before you finish, and then see, what kinds of dot points would you like to have on your CV so you could apply for that job. Okay, so we've got some more comments. Conservator says, by all means, study something that you're passionate about. I think that's right. I would be like, I'm a pretty practical person, and I'm always kind of thinking a step ahead. So, if I was going to study something that was just purely for interest in studying, I probably would have done a science degree. Or if I was going to go back to university now, I would definitely, like, just for fun, I would do an arts degree, maybe language or something. But that's not necessarily going to get you a job that you enjoy, though. So I do think that it helps to balance, but yeah, passion is a really good start. Okay, I've got a question from Rajesh A. How much are the odds to get a job in Germany as a fresher graduating from a German university? And I don't know. I think there probably isn't like a really good answer for that. I think it will depend a lot about what you've done during your degree. The people that I see struggle to get a job after university are primarily people that have focused purely on their studies and not on what they're going to do afterwards. So what kind of work they're going to do, and also getting some experience. So, for example, if I'm hiring a graduate, for me, I don't care about grades. I know that some people do care about grades, but I'm much more looking at what were you doing at the same time that you were at university, and do you have any kind of work experience? I would much rather hire someone that was even, working in a fast food shop versus, throughout their degree, versus somebody who has just got really good grades but never did anything else. And the same for hobbies, like hobbies that are applicable to engineering can be really important. If you're building stuff in your spare time, or something like that, then that's going to show an employer that you can actually do things. And the work, especially, there's a big difference between hiring somebody that has succeeded really well at school and getting good grades. They might need their hand held a little bit more than somebody who maybe didn't get great grades, but they've already been working independently in any sort of area. As an employer, you're probably going to have to spend a lot less time with a person who's worked before than the one who never has. So I would say, if you want to increase your odds of getting a job, then get a job beforehand. It doesn't need to be engineering. Okay. All right, we have a questions from Jawad Mazal. Sorry, I probably said that wrong. I'm going to start a PhD in Murdoch University in WT. I'm trying to think where WT might be. I don't I don't know if maybe it's an American state. I can't think which one it would be. And I'm new to this field. My background in process control. Should I get the challenge? Well, yeah. If you are interested in the new field, then that could be a really good way to get into it. I'll talk about that a bit more in detail when I talk about when and why I went back to uni to do my PhD. But basically, I did it to change fields a little bit. So that can be a really good reason to do the PhD. On the other hand, if you're doing it just because you think that, like it will sound impressive that you got a PhD and you don't really want to work in that field afterwards, then no, do not do that. Okay, from Calico M, if pure maths floats your boat, do physics. If applied maths does it for you, do applied physics or engineering. Yeah, I think that's really good tip. Although I will say that out of the maths that I do, the maths that I like the most is like problem solving, finding proofs kind of maths. So it wasn't the applied maths that I really liked or was good at, to be honest. Yeah, so I think that is good advice, but it didn't actually apply for me. And then got a question about is Australia or Germany good for a master's in mechanical courses? I would here recommend Germany because in Australia it is not normal to do a master's in engineering, and it's nearly exclusively international students. And I will say that many of the programs are really cash making exercises for the universities for masters. I had the choice to do a master's or a PhD, and I chose the PhD because I could get funding from the government to go do the PhD. The master's was not that much shorter, and I couldn't get support. So that's why I didn't go down the master's route in Australia. And I know so few Australians that have masters or PhDs for that matter. Whereas in Europe, everybody gets a master's, and it comes with a really good program with internships. So in Europe, you've always got to do, well, I guess it varies from university to university, but usually you're doing like at least a semester internship, and they're real internships where you go and you work at a company and you're doing real work. You're not just photocopying or something like that. Some of the best people that I worked with during my time in Denmark were interns, and I actually hold that out as one of the best things about the European system relative to the Australian one is you get this like real engineering experience before you graduate. It not only gives you the work experience, which will help you get a job later, but it also helps you figure out what kind of work that you want to do. So 6 months is not long to suffer through something if you've picked the wrong thing. Whereas if it's your first job and you've moved there for it, it's really, really a lot of pressure to make sure that first job is right. So I really think that, the German and European in general system for getting a master's is better. Here's quite a specific question from Murasia Sheikh. I'm just going to do it like a general blanket apology for everybody's names. So it says, should I approach the field of renewable energy, especially wind energy, with a specialization in 3D printing, additive manufacturing, generative design? So 2 parts to this. And the first part is like 3D printing a good field to go down? I think yes. I think it's so exciting. It's really growing. So it's a field where you've got the opportunity to kind of make a difference while there's still problems to be sorted out. I think as an engineer, it's definitely really exciting to work on some immature industries for a while. Like you work on mature industries, and you'll spend your time mostly like reducing costs and increasing reliability, which are important things, but not probably like really exciting like a new emerging field like additive manufacturing is. So that's the one hand. On the other hand, I don't usually recommend that people choose a really specific degree. I have a systems engineering degree, which is like the most broad thing. And I specifically wanted to do it because I didn't know what I wanted to do when I graduated. And, I had this idea I wanted to be an aerospace engineer, largely because I wanted to be an astronaut. And I mean, I would still love to be an astronaut, but in the end, I decided that the, like sacrifices you would have to make to go down that really specific path not worth it for me. And I also, in the end, when I went and did that year in the US, aerospace engineering, I did all the electives for the major, and I realized at that point that if you want to be an aerospace engineer, you're almost certainly going to end up in defense, especially if you want to work on really cool engineering. And I don't have any problem with defense, and I'm glad that it exists and everything. But I personally don't want to design missiles for, in my career. I don't want to work on projects that are going to kill people, like specifically kill people. So for me, I was glad to realize early on that wasn't a path I wanted to go down. And then to have this really broad systems engineering degree, I specialized a bit in the composites and structural design aspect of it. But in work, I've worked so broadly. And actually, the last time I was working for somebody else, I spent a really lot of my time on developing electrical products. So I think if you've pigeonholed yourself too early on in your career, you're not as well prepared to, follow the industry as it changes, because like the things that were, like I graduated in 2005 and, there was no additive manufacturing then. I remember hearing about the idea of it while I was in university, and it blew my mind because it was just so out there and brand new. But we certainly weren't being taught that at university. At that time, wind energy and solar, it was just for hippies that thought that, the planet's health was more important than money. Crazy, crazy concept. But, those industries was not something you would go into if you wanted a job. And I think you could say the same for any interesting field. Now, you don't know exactly how it's going to turn out even by the time you graduated. So I would not recommend choosing a really specific degree. I would recommend choosing mechanical, electrical, something broad like that. And then you'll have every opportunity to specialize, with the projects that you choose, and then with the jobs that you take and the projects that you get given. Okay. Another question from Rajesh. How much is local language essential to get a job in European countries? It depends on the country. In Denmark, where I was, it's not essential at all for work, but it is highly recommended if you want a social life. If you want to be able to make friends with Danish people, then you should at least make an attempt to learn Danish. I think that in general, smaller countries will be like that, where you don't need it for work, but you'll benefit from it to socialize. And then the bigger countries like Germany, it's possible to get a job in Germany without speaking German, but there's a lot of jobs that you'll miss out on for not speaking German. And then in France, it's even times 10 for that. I would have loved to have lived and worked in France, but my French is really basic, and I felt like I would have needed to spend 6 months getting my French good before I could even, start thinking about applying for jobs there. So I think a general rule of thumb is the smaller the country, or the smaller the country's language, the more likely you are to not need to learn it to get a job there. Okay, here's a specific question again. So Prayag VV, what is your opinion about Masters in Wind Energy from Denmark Technical University? Is DTU the best in Europe to study about wind energy? So I don't know. I definitely worked with lots of people who went there. There's lots of good research coming out of that school. So definitely DTU is a good school, and I know that they're producing a lot of good engineers. But is it the best one? I don't know. And I hope that other people are like me in that they don't really care where you went to university. I mean, honestly, it should really not matter. Excuse me. It shouldn't matter. Very shortly after you graduate, you're going to be judged on your performance in the job. I don't know if in Europe people really care about the school you went to. I know that they do quite a lot in the US. I wish they wouldn't. And for me, I don't care. It's a real turnoff for me if somebody, just talks to me a lot about what school they went to and how impressive that is. To me, it feels like you're compensating for something, like maybe you don't have interesting ideas of your own, or interesting experiences of your own. So that's me personally. I can't say that other people don't care about the school that you went to, but I really wish that everyone wasn't so focused on what school you went to. Okay. Here's a good question. I don't know if it's maybe a better one for the end, but I'll just take it now because otherwise I'll forget. So Christopher says, what's a good way to fund ideas? They might not be original or an immediate source of income, but will definitely be life-changing to people. So things for rural communities. That's a tricky one. And I'll talk in a minute about, times when you should maybe consider doing a PhD and when you shouldn't. And that's a possibility. If you can get a PhD scholarship, then that is actually a really good way to work on an idea like that. Otherwise, it's going to rely on who you know, basically. If you if you know somebody that's got a lot of money and isn't too concerned about the likelihood of getting a good return on it, then you're going to need to find somebody like that. Or you'll get a normal job, you'll work on it in your idea in your evenings with your own money until it develops. It is a really common point that people get in touch with me about. So, I've got this great idea, but no one will give me any money. And a lot of times people think this is really unfair. But it's just, maybe it is unfair, but I will say the vast majority of the ideas that I see that, people are really upset they can't get any funding for it, they're usually not good ideas. And I think that that's true in general. Most ideas are not good ideas. You need to have, like at least 20 ideas, I think, to find the one that's really good and worth pursuing. And so early on in the development stage, you should be expecting to do all that yourself and with your own time, your own money. And then once you have gotten to the point where you have demonstrated that the idea is plausible, then you might think about getting other people to invest. That's my opinion on that. Okay, I've got lots more questions, but I did want to go to some of the other questions that I get asked a lot. So this is the most common question that I get asked, which is how to choose a research topic for like an undergraduate project assignment or for a master's or PhD research topic. And I do get several messages every week from someone saying, I'm about to do a master's. I need to choose a topic. What should I study? And I always say that I can't tell you what you should study. And in fact, I really don't want to tell you what you should study, because that's actually the point of doing a research project isn't to advance the state of knowledge in that field that you're researching. The point of it is what you're learning. And the most important thing that you're learning is how to choose an interesting research topic. So it is very difficult. And I mean, I struggled with this when I did my PhD. I guess I spent most of the first year and figuring out what to study. And then even beyond that, you're still kind of figuring out the precise details of it nearly right through to the end until, you're actually finishing off your thesis. You're probably still tweaking things. So it's a big part of it. And it's very daunting because you need to find something that hasn't been done before. At least for a PhD, you do. For masters and undergraduate, you don't have to, but it is more interesting to do it that way. So you need to find something that's never been done before, but also something that you can do. And that's where I really struggled with I guess it's a confidence thing. It's like no one else has been able to do this before, but I'm going to be able to, some, like brand new student is going to, take it further than all of the professionals already working in the field before. And I mean, that just feels incredibly daunting. And not only that, so you need to find something that hasn't been done that you can do that will probably work, because even though technically your PhD project doesn't need to work, you could make a PhD project about something that will never work. You're going to have a much easier time getting it passed if, you found something and it actually worked. You got some positive results. And then also, you would like it to be meaningful as well. I mean, most students want to. I definitely wanted. I didn't want to, study something really obscure. Excuse me. I wanted to study something that could have some application. So that's really hard. And I'll tell you the recipe book approach that I use to find out what is a good topic. And so when you're starting out with a new project, you're going to start out with a literature review. So, you have an idea about what sort of area. For me, I had the idea, I wanted to go to university to change field, basically. So I wanted to work in the wind industry. Actually, maybe this is a good time to, let me just share the screen, because I'll move on to my early work experience that I did. So now I'm stepping back a bit. Sorry for the abrupt change. But yeah, so while I was in high school, I did casual jobs in the bike shop, swim school instructor, taught clarinet to teenagers for a while. So it's like I was saying, like just any kind of work experience is going to help you get, just experience it, basically just looking after yourself and working without someone telling you what to do all the time. I did my work experience in 2003 as an electrical engineering assistant at the Film and Sound Archives in Australia, and that was a really cool job because I just kind of went around when there was like film equipment would break, and I would try and figure out why it was broken. Usually you just like sniff a circuit board and find the burnt out capacitor. That's what I mainly remember about that. And then my last few years of university, I got this job as a research assistant at an environmental science research school, and that was just the funnest job because I would go hiking in like places like there's a water reservoir in that image there. I would just, like hike in there all day to help some PhD students or researchers get water samples and then hike out again. And that was just like a really nice way to earn money. And then after that, I briefly worked as a graduate engineer at a water utility. That was like a graduate position that I got, and it really, really didn't suit me. So I left that pretty quickly and got a job at a startup solar energy research company. They were called Zysol, and they made this kind of solar panel that was a bit like artificial photosynthesis. And I worked there for a few years until I actually left because I had an injury from a car accident and I needed to work from home. And back then that was like a huge, big thing. And I wasn't allowed to work part-time or work from home some of the time. So I left that to be an independent consultant. It's so funny to say that now because obviously everyone's working from home now and, we figured it out. But back then I had to leave that job. So then I was an independent consultant doing mechanical design and project management, and I worked on a lot of different kinds of sustainable technologies, a lot of other renewable energy startups. But I found it pretty frustrating because I was working on all these small scale things that were basically being funded by research grants from the government. And I could kind of see that they would never go anywhere once the research grants dried up, that there was no real business case. And I was like, I'm working in renewable energy, but I don't really feel like I'm actually helping the climate crisis. I didn't feel like I was actually contributing to any solutions. So I wanted to work on something really big with a lot of impact. And because I had that background in aerospace and I've always loved composite materials, that was my major in my undergraduate degree. So I decided to go back to university. And I went to the University of New South Wales, that Canberra campus specifically. University of New South Wales, its main campus is in Sydney. But the Canberra campus, it's part of the Australian Defence Force Academy. All the undergraduate is defence, but all of the postgraduate is civilians, mostly international students. I was the only Australian in my group, actually. My thesis title is Improved Design Methodology for Large Radius Composite Wind Turbine Blades, which is a very catchy title. And basically I used data mining and optimization to create a better way to design wind turbine blades. And then I've got this picture here with a novelty check, which I found like incredibly exciting. I always wanted to win a big check like that. And I got it from doing this competition, this 3-minute thesis competition. And I just wanted to show you the video that I did actually. Climate change is a problem that our politicians don't seem to be trying particularly hard to solve. Long-term solutions are required, which are incompatible with a narrow focus on re-election. This used to frustrate me until I realised that as an engineer, I have the power to change the world. And unlike some politicians, I choose to use my powers for good. So, in my PhD, I'm helping to make wind energy cheaper than fossil fuels. That way using it will be an economic choice instead of a political one. Wind power is actually already the cheapest type of energy in places where wind speeds are high. That's the red areas on the map. But the good sites are filling up fast. So if we want more wind energy, we need to develop more low wind speed sites, the yellow areas. But lower wind speeds means less energy. So to make up for this, low wind speed turbines have longer blades to reach more wind. But making the blades longer creates design challenges, which means they use more material and so they cost more. I'm aiming to reduce the cost by redesigning low wind speed blades to use less material. To do this, I've created computer models of high and low wind speed blades and simulated the loads they face to compare how the structures respond. For a high wind speed blade, the main challenge is to make it stiff enough that it doesn't hit the tower in strong winds. That's important for a low wind speed blade too, but they face an additional challenge. Because the blades are so long, they bend a lot under their own weight, which is a problem because turbines are constantly rotating. And after enough cycles of bending, the blades can break, just like if you bend a paperclip repeatedly back and forth. Now, the normal way to make a wind turbine blade is in two parts. There's an external shell, which makes the aerodynamic shape needed to turn the wind turbine and generate electricity. And inside there is a box spar, which works a bit like the trusses that hold a roof up. In both cases, it's the inside part that makes it strong and stiff enough. Now, this design works well to stop blades hitting the tower in strong winds, but I found they don't do a particularly good job of stopping low wind speed blades bending too much under their own weight. So I came up with a new design that takes some of the strength away from the box spar and into the aerodynamic shell. Now, instead of being like a roof, it's more like an egg, where it's the outside surface that makes it stiff. This design is still good in strong winds, but now it bends much less under its own weight, which means it can use less material and so it's cheaper. Because of engineering solutions like this one, fossil fuels are gradually being priced out of the market. And best of all, because this progress doesn't rely on politics, I'm confident we'll actually get there. So that's pretty funny to watch back. I think that was 2014. So I was only a couple of years into my PhD at that point, and the topic did change quite a bit. And also, I mean, like any kind of science or technical communication, it's easier if you find like the part of your research that's easy to describe rather than trying to describe the real essence of it. So like the really interesting part of what I did was in the design method. It wasn't the result of the design, which is what I talked about there. But it is interesting to see that, I kind of like went through a little bit about my my design philosophy, or my philosophy for why I think that renewable energy engineering is important. And yeah, that's still true today, where I really feel like I have more chance of impacting our action on climate change by working on the technologies rather than the like convincing political stuff. It's partly because I'm not a political kind of person, and I don't really like talking to people who I disagree with to persuade them about, like a moral thing like climate change. That's not like really strongly in my skill set. But I also do really think that over the last decade, it's 7 years since that video. I mean, think of how far we've come. We're at the point now where we have COVID economic recovery packages that are also climate change packages, and the only reason why you can have an economic package that's also a climate change package is because the technologies are there. So I look back on that and I'm like, yeah, that was a good decision that you made. Yeah. So anyway, I just wanted to go back to what I was saying before, which is like, how can you choose a topic? So for me, I knew that I wanted to work on wind energy. And actually, there was a question somebody asked. Sundan says, real question now, why did you decide on wind over solar? And for me, his 100% because for me, that's the more interesting technology to work on. I love composite materials. I always have ever since I was like 11 years old. I started cycling competitively, and the best bikes are carbon fiber. I saw, like how you can make cool shapes and light structures, make aeroplanes and rockets and Formula One racing cars and the fastest bikes, skis, like everything cool is made out of composite materials. So that was why I've always loved that. And then the aerodynamics as well. My aero background is very useful for wind, even though I'm focused on the structural things. There's like a huge interaction between the aerodynamics and the structure. So I just combined the things that I like purely just because I find them interesting, and chose wind. If you're more into chemistry and certain kinds of manufacturing, then solar would probably be more your way, or an electrical or electronic kind of engineer. So that was it for me. So anyway, I knew that I wanted to go into that field. I had studied composite materials in my undergraduate degree, but it's pretty complex. You can't really get into everything in an undergraduate degree. So I knew I would need to at least do a master's to be able to get a job in Europe, which was my plan, to get a job at a real manufacturer making like real volumes of renewable energy. So I chose a PhD topic like that. And then you've got to figure out, okay, so I've got these like broad goals of what I want, but what is my topic going to be? And so I'm going to share my screen again. I've got some PDFs here. I'm going to show you like the exact method that I use to find a topic. So you're doing your literature review, and you're probably just reading stuff that's interesting to get started. You're finding out what the state of the art is, and you kind of get a sense for what a big problem is. And for me, I was reading a lot of papers of optimizing, using optimization to design wind turbine blade structures. And I noticed that everybody kind of like really simplified that problem to be able to get the design space small enough that you could actually, run it through an optimization algorithm. Because, like if you actually think of every single variable in a wind turbine blade as, hundreds or thousands of different decisions you've got to make, and that's too much for an optimization algorithm to actually get to. So I was reading papers about optimization, and then you go to, and you'll do this for whatever topic you're interested in. You read papers, and then you go to the section that's like called further research or something. So we can just like Control F and write further in here. And yeah, that takes a little bit. Okay, so here's one. The further investigation is needed before any of the design constraints can be eliminated. So if you see this in somebody's paper, then you're like, oh, okay, so further investigation is needed on this. And, like you've got a real researcher that's saying this is a problem that deserves attention. So not every time I say further is a good example of that. I'll also go to this. It was a paper I was talking about in the last live stream on vertical axis wind turbines. They did some study, some analysis, and then they've got a search for the word future in this case. In the future, the study has a scope of extension on bigger infrastructure by adding more turbines or going three-dimensional. So it's like, there you go. There's somebody there has suggested something that they think would be a good next step to do. And that's basically the shortcut to finding a good topic for consideration. So yeah, now when people get in touch with me saying what topic should I do, that's going to be my answer to them. You start doing research on an area that interests you. You zone in on some sort of like gap that you think that people haven't been investigating but should be. And then if you want a real shortcut, you search for future or further or like additional research needed. They always have a section like this, like at the end of every academic paper, additional research, and you find a topic, and then you'll check to make sure that somebody hasn't already done that since, and that's it. That's how you can choose a good research topic. Okay, I'm just going to check for some more questions. So we've got, was your research related to material and mechanical engineering in wind turbine blades? Yes, it's both of those, a combination of both of those. So I was in the composite materials research group within the mechanical engineering department. I was working on structural methods, but the new stuff was about using like data mining to an optimization to design a better structure. I didn't like invent any new ways to do structural analysis. I just used existing tools and then borrowed from like computer science and combine them to come up with a better way to design wind turbine blades. I think somebody asked earlier if that's being used anywhere, and I would say that no, the research didn't specifically get used, but I have noticed that certain aspects of it, design methods have gone in that way. So I felt like I did something real, and then that would also touch on the next question a lot of people ask is like, should I get a job in industry or should I stay in academia? And for me, as an engineer, for me, industry is easier to have an impact in a career in industry. So I was really proud of my PhD research, and I think it was good, and I think it could have been used by a company. One reason it wasn't is because I was just so sick of that topic. By the time I got a job, I did not want to work on it. So that's that's on me. But I think in general that's true. Like, you do a lot of really good research in academia, but it's not as likely to get used. Whereas in industry, you're going to be, making a lot more simplifications. You're probably not going to be doing like a smart work, but it's real work. You're solving the real problems, not some, problem that an academic got the idea might be a problem, but, like an actual problem that's faced by industry. Here's one from Hashim. I want to start a bachelor in renewable energy engineering in Swedish university next year. What could be the best skills to learn or the best courses to combine with this to be more effective? So, I mean, it will really depend what you want to go into, but I would strongly recommend that you get some solid traditional engineering subjects and skills in addition to the renewable stuff, because all the renewable specific stuff you can easily learn on the job. You can be a mechanical engineer and then you'll get hired for that and you'll learn all the wind industry specific stuff when you get there. And I think that that's much more like future-proof kind of thing to do, to get those solid skills that you could change industry. Because, like I mentioned before, we really don't know how the industry is going to evolve. So without knowing exactly what you're interested in, it's hard to say what you should work on. But maybe a good idea is to take a look at some job ads for the kind of job you might like to get and see what they're asking for, and make sure that you get those, and especially that the projects that you choose are projects that are going to be good for you to talk about in an interview. Okay. I also wanted to talk a bit about whether you should do a PhD in engineering, because that's another question that I get asked all the time. Actually, when people ask me this, they've always decided that they're going to do a PhD, and they're asking for advice, but they want me to just tell them to do a PhD. And usually I'm telling them don't do a PhD. So it's kind of a funny conversation that I frequently have. So I did a PhD, obviously, and I am really glad that I did. And it was perfect for what I wanted to get out of it. And I definitely don't regret it. So I have made a little bit of a checklist of reasons that people might consider getting a PhD. So number one, you can't think what you want to do after your bachelor's or master's degree. Or two, you can't get a job after your bachelor's, master's degree. And I think that number one, if you can't think what you want to do after your bachelor's, master's degree, you definitely shouldn't do a PhD next. You should get a job, any kind of job, so that you can figure out what you want. Because if you just do a PhD not knowing what you want, you're going to end up with a PhD that is on something that's not what you want to do, and then it will not be valuable to you. Two, if you can't get a job after your bachelor's, master's degree, then I think that could be a good thing to do. But I do hope that you're going to choose it, like mindfully, so that it helps you get a job when you're finished. I'm going to talk a bit more about how much a PhD helps you actually get a job. Third reason people say is they're just really interested in a particular topic and want the freedom to study in more depth. And I think that's fine, but you might consider it like a holiday from work rather than, a qualification that's really going to help your career in the long run. 4, you want to work in a field that requires more depth of knowledge than you can get from work experience. For me, that's basically why I did mine. And so, I do recommend that as a good way to do that, or to make a slight career change into another direction. 5, you want to become an academic or a lecturer or a researcher. And in that case, yes, you'll need a PhD, but I would encourage you to investigate what it is like to work in one of those positions. And there is a group on Facebook and Twitter, I think, called Shit Academics Say that I followed, and I continue to follow it. And people post, all the incredibly irritating things about academia. Definitely recommend following that before you make the decision to go down that career path, because it is a really hard and not well paid, not that well respected kind of career path for many people. Reason number 6, you think it will increase your employability. It may in specific circumstances, but in general, a PhD in engineering is not a ticket to a better job. Another reason people say is, you've always been smart and smart people do a PhD, or you want the respect that goes along with a doctor title. I don't think that is enough of a reason on its own to get you through a PhD, but in combination with something else, then sure. And then reason 9, you want to investigate a new technology's potential before starting a company. That's something that I mentioned before when I got asked about funding. That I think is actually one of the better reasons to do a PhD, especially if you can get a scholarship or something, then that can be a good way. But just make sure that your university allows you to keep your intellectual property. Otherwise, that will be a terrible decision. Another reason you want a residence permit for another country, and student visas are easy to get. I think a lot of people, especially in Australia, do it for that reason. And, that's a means to an end. And then reason number 11, if you're a woman in a male-dominated field, and a PhD can act as a sort of shield against patronizers and mansplainers. And that's, obviously a bit of a personal reason that it's not why I did a PhD, but it has come in super, super handy in many situations. I know at one point in my career, I was having real trouble with this group of people I was working with, and from a different company. And I just put my PhD in my email signature, and things improved. I started getting started getting respect a bit more easily. So that's kind of funny. So I think all of those things are fine reasons to do a PhD. You need a combination. Some of them aren't enough reason on their own, but I will caution people who want to do a PhD that some things you might think are true are not going to work out that way. So think about, do you really want to be an academic? It is not an easy job. I would say it's a pretty shitty job in many circumstances. If you're a star researcher and you're not having trouble attracting funding and getting tenure, then I'm sure it can be good. But the vast majority of people really struggle. They make terrible money compared to if you're working professionally, and you still don't always get to work on what you want, because you do have to work on the stuff that will get the grant funding. Spend a lot of your time teaching, so you don't have as much time left over for your research as you might think. And then about the jobs thing, in a lot of cases, you're not going to find it easier to get an engineering job with a PhD than without one. So there are exceptions, like research-based companies and institutions. And in certain countries, there is a ton of respect associated with the PhD. And I've noticed Germany in particular, Germans really attach a lot of respect to someone with a PhD. But my experience has been employers are not more likely to give you a job, and they won't start you at a higher level, or at least not like maybe you'll start like 1 year ahead of somebody who's a fresh graduate, but it took you four years to get the PhD. They won't pay you more because you got a PhD. And for engineering, nearly every case, 4 years of work experience will almost certainly be worth more to you than a PhD. And some employers will consider it basically like a 4-year long career gap. So if you are going to choose to do one, you need to keep your eyes on the prize. You need to really know what you want to gain from a PhD. There is a strong risk if you just kind of go with the flow. There's a strong risk you're going to end up providing like sub minimum wage labor to your supervisor if you don't have clear goals in mind, and importantly, like respect the value of your own time. So while I was studying, there was a lot of people who had applied for a specific PhD project, like they already knew what the subject was going to be, what their PhD thesis topic was going to be. And one of those, like a specific example, was what me and some of my colleagues called cake making PhDs, which is where like you take a specific, it's just in composite materials, and so that's, you have a fiber and then a resin matrix, and that gives good structural properties. So a cake making PhD would be like, oh, you change the resin, or you change the fiber, and then you test the structural properties and see if it's good. So the cake analogy is, okay, so I can make a cake out of wheat flour. Let's see if I can make it out of potato flour, and does it still taste good? Is it crumbly? Is it is it structurally sound? Those sorts of PhDs. So I saw a lot of people complete PhDs like that. They diligently followed everything that their supervisor told them to do. They got their 3 journal papers published, got through, but it wasn't a topic they had a real passion for, and they didn't really know what they would do with it afterwards. And also they struggled to get a job afterwards because their topic was so niche. So I don't see a lot of reason to do a PhD on a topic that you're not passionate about, that it doesn't give you a clear path to improved employment prospects, not just like in terms of someone giving you, more likely to give you a job, but also that you'll enjoy that job. Yeah, so that's my that's my big thing about should you not do a PhD. And it is pretty negative. Maybe you think that for someone who did a PhD, like sounds like I'm really strongly against it. And I mean, like I said, I'm not against doing a PhD, but I am against doing it mindlessly. You really need to have specific goals that you want to get, and then work towards those. And remember, you don't work for your supervisor. You're there. You could be earning money in a job, and you're there earning either a lot less or nothing, or paying for the privilege. So it should really all be about what you're learning. Okay, so getting pretty close to probably how much time I wanted to spend on the podcast today. So I'll just go and check if we've got some more questions. So John Coppola says, I think when I was talking about the reasons to do a PhD, you want more out of life, and yeah, that could be part of it, but I don't think that it's enough on its own. I think people who do PhDs for the passion will usually find themselves at the end of the PhD with a similar issue to before it. So as long as you're aware of that I guess what I'm really trying to say is it's not a guarantee to a better job or a more satisfying career. It can form part of your journey towards that. Okay, and John Coppola, same one. Money isn't everything. Money isn't everything, but it is actually quite a lot. If you are choosing between, following a job that's your passion and pays badly, or one that you like pretty well and pays well, think about your overall life enjoyment. If you are in a job that pays badly and leaves you constantly chasing, funding for it, then you're going to have a lot less energy left over for anything else that you enjoy in life. If you have a job that is paying you well and you enjoy it okay, you'll probably have energy left over to, do a passion project on the side. And I think that, you need to weigh those two options up. Think about your life as a whole, and a well-paid job can make your life much easier and make you more able to pursue your passions. Okay. Oh, sorry, I keep on picking the same commenter. I'm not doing it on purpose. So, what are the positive aspects of being a professor? And that will depend on what kind of professor you are, because in a lot of academic markets, there's just way too many people. There's, not enough tenured positions. And so a lot of people are adjuncts and they just end up just teaching for not very much pay. And so they have to teach a lot of courses and they have no time left over for anything else. So that would be an example of where, like, unless you actually specifically wanted to be a university teacher, that, that wouldn't be a good way to be a professor. But I mean, the professors that I see with good careers that I, would like to have, the benefits there are that they're working on a bunch of different stuff, like they can work on, when you work for a company, all the projects that you work on are going to be related to, a product for that company or making that company money or saving them money in some way. When you're a professor, you might be working on, like airplanes in one project and wind turbines in another project. And I don't know, you might just any number of different projects from totally different industries. So I think that for me, that would be the most appealing part of it. Second appealing part is the what am I trying to say? The research facilities. If you're at a university with good, equipment, if you've got a wind tunnel or a shock tunnel or, like materials testing stuff. In industry, it's hard to get that really cutting edge stuff because it's very, very expensive. And at universities, if you've got a well-funded research project, then you can do some really, really cool stuff like that. That's probably another big advantage. And there would definitely be more there. Also, you've got a lot of freedom. You don't. They have deadlines, and I know every academic that I know works so many hours. Like, it's just so many. So I'm not going to say that it's like easy, but you to a certain extent choose your own deadlines. Like if on projects I was working on in industry, you're designing a new product and testing it, and it must be ready on this date because that is when the blades are going to be made in the factory, and then a week later they're going to be installed, or they've got they're booked on a ship, and so it's kind of all laid out, and it's so much pressure to reach that deadline, and there's not usually that same kind of deadline in academia. And Richard Newton suggests some positive access to being a professor, holidays and free lab coats. I think the holidays one, there probably aren't that many professors that are getting a lot of extra holidays, because I think that's a lot of them is when they do their real research, their real writing is during the holidays when students aren't there. Free lab coats. Sure, that's a big plus. I actually got a free lab coat with my name on it in one of my first jobs that I had when I was working at the solar research company, and I definitely saw that as a huge perk, and I still have that lab coat. So from Sondon, I have a doctorate, and it doesn't matter your field, it doesn't always mean more money. Yeah, definitely doesn't always mean more money, but it is a nice little extra negotiating thing. And for me, you wouldn't do it purely for the money. I don't think in any case it's going to be a ticket to definitely more money. But given that I did it for other reasons, like I wanted to change field, and I wanted to get a deeper level of knowledge, then it would be easy to get from self-learning or learning on the job. Then I feel like, yes, there is a small bonus of I've got a PhD and I can use that in salary negotiations to differentiate myself from someone who doesn't. But that said, I spent 4 years doing my PhD, so PhD, 4 years extra work experience. I mean, I did work throughout my PhD as well, so I didn't not full time, just very part time. But yeah, so it's just an extra like bargaining chip, I guess. Okay, so my Aunt Cheaton, I've experienced issues getting jobs because of my PhD. They feel a bachelor's or master's student could do a job at lower cost to them. How would you recommend overcoming this issue? Yeah, so I guess this is the thing that I was saying, is that people aren't going to attach weight to the PhD specifically. So, I mean, given that you've already done your PhD, what I would suggest is you've got to think about it like it was a job. And when you're writing your CV for any kind of job, whether you've got a PhD or not, you're going to be going through your previous work experience, and you're going to be picking out like what are the things that you specifically did. What did you bring to that role? So I would be trying to find like the the unique angle that you took, or the idea that you specifically had that took this project in a different direction to how someone else would have, the problem that you identified and the creative solution you found, you came up with to solve it, the ways that you attempted to validate that and obstacles you overcame. Pick all of those out and talk about it much more like it was a job, so that they will it will feel more to them like you were working for those 3, 4, 5, however long years it took you. I think that that's the best way to approach that. And yeah, I feel for you, because I see so many PhD students surprised at the fact that people don't value a PhD in engineering as much as maybe you'd expect, because it's different in other fields as well. Like in science, I think it's very, very different, because there is a different level that you can reach with a PhD in science compared to what you can in industry. But engineering is such a practical applied thing that, like real engineering does happen in industry. Oh, we have I can't remember what these things are called, super chat, but there's a donation from Sanjeev Soni. He says, hi, and thank you for that. Okay, from Sundon. My nephew said his favorite professor was a guy who worked for 20 years in the field and has then come back to teach a bit. Yeah, that's the same. When I was in high school, one of my best teachers, he taught me statistics, and he was an ex-professional gambler, and he came back because he just really wanted to teach. And I know other people, like when they say their favorite teacher was someone who had worked successfully doing something, but just really had the passion to share. I also agree those are the best kinds of teachers, and especially in engineering, the ones that have worked in industry have got something really different to offer. And I know a lot of universities are pretty keen to get professors who have some industry experience, because it is, most of their students are going to go into industry. So I think that that's really, really, really useful. Okay, just trying to find a few final questions, then I'll wrap up. Okay, so here is another one. From Mario Salazar, what do you think the current bottlenecks are for renewable energy, tech, politics, etc.? So I mean, it's a little bit of everything, but I think for the most part, like most of the technology is there. There is a few remaining parts, but it makes up maybe 10 or 20% of emissions that technology needs to improve for. For the most part, we need technology improvements to get costs down and scale up. That's the main thing. So, like for batteries, for example, will really help a lot if they get a lot cheaper. Politics, I mean, I see so much change now since, when I did that 3-minute thesis, I was so frustrated by politics. Like I was so frustrated by Australian politics that I actually left Australia because I couldn't handle it anymore. And I mean, in Australia specifically, the politics maybe haven't gotten a lot better, but in our government specifically, but it's pervaded now. So now you don't have to be a hippie to work on renewable energy. When I started working that solar research company, it was just like really idealistic people just hoping that everyone would value the planet more than the economy. And now it's not like that. The people that I work with now just, some of them, in the wind energy companies, some of them didn't even believe in climate change, but they still could just see that wind turbines are a good way to make energy. And the same with all the like EVs and batteries and everything, solar, everything has come so far that now it's there. The technology is there that the politics doesn't matter as much. And you see businesses investing in renewables even without being forced to by the government. So that's something that I didn't even imagine 10 years ago. So I'm really pleased with, how much the technology and the politics have come along to the point where people do demand climate change policies from their governments now. So that's not something that I always assumed would happen. So what I actually see the biggest bottlenecks for renewable energy or for the clean energy transition as a whole is regulations and markets, business cases. That's where I see that's what I see that we need to be able to roll out the technologies. We have them, but we need to roll them out much faster than will just naturally happen by, kind of leaving all the markets and everything as they are. So I'm really excited about things like, well, energy storage, but also load flexibility. So instead of, making electricity when there's a load for it, instead you will use electricity when it's generated. I think we can do so much more like that and really, really save a lot. And like electric vehicle charging will be a big part of that, and industry, and then maybe also smart homes. And yeah, all kinds of other regulations. I mean, I'll talk for 5 hours about this, so I won't go into it too much. But for me, that's the single biggest thing that we need to solve. Daryl W says, I think the biggest bottleneck is the not in my backyard syndrome, definitely here in the UK. And we get that here in Australia too. And I was just reading, I was talking about that on the podcast that I co-host, the Uptime Podcast. We were talking about that in France. I think that's a big problem too. I know it's a problem in Germany, I think for sure. And I can kind of understand it. I mean, I love nature, and I definitely prefer that nature is pristine. I don't want to see, every forest cut down to make solar panels or wind farms over every ridge at all. I also don't want to see, coal mines and coal power plants putting soot all over everything. So the reality is, if we want energy, then we need to make it somewhere and it's not impactless. But I am pretty excited about offshore wind for the possibilities of scale, because I don't see that we can scale up like onshore wind and solar to the extent that we would need to get to 100% renewable. So I'm excited about that. And yeah, I think it is important that you do get people on board with having the renewable energy in their environment. So I see a lot of good community engagement programs before projects start. People are learning a lot from early mistakes. All right, so I'm going to leave it there. I think that was quite a long one today, but yeah, I'm really, really pleased at how many good questions that we got. Thanks everybody for showing up. I was a bit worried that we wouldn't see a lot of students and early career people showing up, because I know normally when I look at my analytics, I find that most of my viewers are in their 50s and 60s or older. So yeah, really excited to get to talk to a lot of people who are forming the next generation of engineers. And I think that, the future is in good hands. I need to thank WeatherGuard Lightning Tech. They sponsor this live stream. They make a lightning protection system called Strike Tape, and that can be quickly retrofitted onto wind turbine blades and aeroplanes to improve on the factory lightning protection systems. I also do a weekly podcast with those guys, with Alan and Dan. So you can check out the latest podcast episode. There's links in the description to the different podcast apps, and you can also watch it on YouTube. So we talk about tech news from the wind industry and other clean energy topics. In the most recent episode, we talked about birds and wind turbines, which I know is a very anytime. People are constantly raising the topic of birds and wind turbines in my videos and video comments. And there's this American group called ABC. I think it's American Bird Group or something like that. And they're becoming increasingly hostile to any new wind farms. So check out that segment. And then there's other topics we talked about this week, like my old employer, GE, splitting up into 3 businesses. So yeah, check that out on your favorite podcast app, or you can watch it here on YouTube. I also need to thank the Engineering with Rosie Patreon team for their support. And I'll just also put up the link. So if you want to join the team, it's a great group of people. We talk about everything related to the clean energy transition. We've got a Patreon only Discord server. So if you want to join the team, support the channel's growth, and help steer the future direction with video suggestions, and I always ask for questions ahead of interviews that I do, then you can join us in the link that's in the description as well. The next live stream is going to be on November 30th. I think that's my time. So if you're not in the Australian time zone, it will be the 29th. And it's going to be on batteries. I have a really, really good expert guest lined up to talk about everything about batteries and how they're used in the grid. So like what kinds of batteries for what purposes, and like why can't lithium ion batteries just do everything? And then there's been some interesting stuff happening in the Australian energy market recently. We've had a lot of negative prices in the middle of the day because we've got so much rooftop solar. We're going to talk about how battery is going to fit into all that. So yeah, check that out in a couple of weeks. I'll see you then. And yep, just thanks a lot. See you next time.